Welcome to this talk about my tool, the WCE, the Window Commander and Exfiltrer, which a tool aims to gain as much stealth as you can during red team operations, during GTAs, and even doing data exfiltration from inside the network to outside it, and surely um, during the communications between you, for example, and your victim hosts, or even between you and your remote machine inside a network. I'm just gonna talk about myself right now. I'm Momen, a senior penetration tester and a red team operator at Samurai Digital Security Limited. Um, I'm interested in security researching, the zero-day discoveries, low-level stuff, and surely the red team operations. And today we'll talk about the WCE tool, the Window Commander and Exfiltrer. First of all, we'll talk about some concepts for this tool because the concept or the detailed concept and the detailed inner working for this technique, because it's not actually about a tool. The tool is just an implementation for a technique that we worked on, will be surely explained later in a later talk today as well. But now we'll just explain concepts about the tool, how it works, how this technique works actually, how it can be used, and how it can be beneficial for us as red teamers. So first of all, the tool or the concept of exfiltrating network, let's say exfiltrating commands, for example, to be executed, or exfiltrating even the data, it's just for being steal. In the past years, if you just look at how attackers being steal in the network, you will see that with the evolving of today's technologies, especially after like the AI, the AI and the machine learning stuff that has been invented and now been widely used during the antiviruses and also during and also by like the EDRs and IDS, IPS, etc., you will see that it's a little bit hard to still use the same techniques for exfiltrating your data or even for exfiltrating commands. For example, previously, to exfiltrate some stuff from inside to outside the network, you can try exfiltrating them through DNS records, DNS, for example, subdomains, let's say, etc., etc. But now it's not gonna work. Also, modern adversaries were exfiltrating commands through MQTT protocol because it's not that common protocol, because MQTT simply can be used in many ways, and at the same time, not the whole security solutions will look for malicious MQTT protocol in that time. But now it's much smarter. We have smarter tools to detect. We have smarter security solutions, and at the same time, we have smarter and trained blue teamers. So we need a new way to exfiltrate our commands, for example, for the command and control. And at the same time, we need more like brilliant ways and brilliant concepts and tools that allow us to do that or to approach that. Simply, the applications or how this tool can be used is not actually limited because it's a technique. For example, let's say you are now building a C2 framework and you want you want to exfiltrate, for example, and communicate with your victim machine, with your, for example, insider machine, etc., inside a network. You want to exfiltrate the data and you want to communicate in a stealth way. But the encryption and the encryption and the old stuff now will not work. So how to do it? This is a way you can use this concept and this tool for. Also, if it's gonna be much simpler, like you just like rooted a machine and you want now to communicate with your rooted machine through a very stealth way, because after rooting a machine, for example, or even after entering the machine through like a root user, let's say this machine only operates with a root user. Most the IoT devices right now, and for example, are only running root users. So you already root in your machine, and you want to communicating command and control your machine, but without having like but without actually having everything leaked in the network packets, because there is no encryption. And if there is an encryption applied, maybe this is not the ideal way to do it, because it's not very common in the network. Machine learning modules, for example, will look for the normal and the ordinary traffic. So there was no communications encrypted before, for example, through a specific, let's say, a protocol. It was just like normal TCP packets or even SSH, etc., etc., and also with specific specifications and requirements to be legit. Okay, so this is how our tool works. It will simply convert a natural, very natural TCP packet to an evil one without even causing any problem or any red flags in your network, or even for your antiviruses, for example, the network monitors, etc., because there is no specific execution, for example, or bad execution is going on here. It's just normal packet, but with our applied algorithm, for example. Now, here you will see how it works, but from a little bit high level perspective, because as we say before, the deep understanding for the tool and how it works will be explained later in a later session. So here, for example, we have two parties. We need to think about a way to, for example, let's say command and control, or even to exfiltrate data from this person, which is the attacker, aka the commander here in our algorithm here, and then the receiver or the victim. If you just give it a think, you will see that it's so legit. Just think about it. Here, for example, let's talk a little bit about the TCP packet. Our TCP packet consists of a lot of stuff here, for example. Okay, so we have, for example, some TCP flags, okay, like the ACK, the SYN ACK, etc., etc. Okay, and then also we have the window, for example, here as a part, as a segment of this TCP flag. Okay, and because we can simply craft a TCP packet from the zero, and it's gonna be implemented, for example, let's say from a high-level language like Python, just to make our mission easier, and the debugging for our algorithm, if anything bad happens, or if we want to develop it, will be much easier than like developing it in a low-level language. Okay, we are going to talk in using Python for this in this context. So here, for example, we have a TCP flag like the window flag here. The window flag simply specifies the amount or the size of data that actually exists in your TCP payload itself. So simply here, the only stuff that you will see inside the window flag, and also you can see here, for example, from a Wireshark perspective, it's only numbers. Specifically, it will be decimal numbers. Okay, and because it's actually decimal numbers, and because we can simply craft our own TCP packet, so that means we can simply craft our TCP packet with like window or malicious window flag value injected in there. And simply from the first time you think about it, you will find it's a little bit not worth to try, because simply you can just like craft the packet in a wrong way, or just like having like a little bit of concerns, for example, about if it's gonna work or not. But if you just give it another thing from a deep perspective, what's value that can be evil inside a window flag? There is no value can be evil in there. It's just numbers. And also we are going to obfuscate the numbers, but without even changing how the numbers like implemented in the TCP packet itself. For example, it's gonna be the same number, the same syntax, and literally the same everything in a separated packets. So simply everything will be very normal in a network infrastructure, for example. And now, surprisingly, we don't have to send these packets to a specific IP address. For example, there is no actual need to have like, or to know the IP address for our machine, for example. It's gonna be pretty easy to know it in a real life scenario. But here we don't even communicate with the victim machine. There is no actual communication is actually happening here. It's just a concept of monitoring the network from our victim or from our receiver, for example, seeking for a specific packet in the whole network, coming from a specific location and coming from a specific with specific requirements and with specific specifications, and then extracting a specific value, which is gonna be the window value here in our scenario here, and then doing the conversion from that window using our algorithm to be reversed into the original text, for example. Now, for example, here, before even sending the packet, multiple stuff is being implemented here. First of all, we are actually converting the strings into another strings that is not the real one, aka encoding. So here, for example, we are going to encode it to ROT13. And there's no need to make it only ROT13. You can make it ROT10. You can make it ROT, let's say, 11. You can do whatever you want because this is your algorithm. And the tool is clean coded. So you can simply go there, change the algorithm, develop it, enhance it, and simply you are in. Because nobody, for example, will simply think that this may be an encoded character. And here the encoding will not affect our syntax when it comes to the decimal base 10, because simply the decimal base 10 is the second stage. So here, for example, we are encoding it in ROT13 at first, and after encoding it, we are like converting it to decimal base 10 in order to be an ordinary number. So here, for example, you will see the number 99 here transferred in the window here. It's not a big number, and it's also actually relatively small number to hold, for example, let's say a malicious value, for example, or let's say a TCP packet that can be used in denial of service, for example, in case of like trying to exploit something or trying to exploit a vulnerable service that is vulnerable to a huge amount of data or being held inside a TCP packet, etc., etc. So it is not going to be malicious at all, even though this technique with the manipulation can also be used out of this scope, of executing commands or even exfiltrating data. Because simply, even if your packet is holding like a huge amount of data, for example, and you don't want your packet to get captured, you can simply implement another algorithm to simply manipulate the values inside your TCP packet, and then you can simply transfer your data in a safe way, as long as you know how to like excel the algorithm that you're going to build. Anyway, so now after creating and converting our like characters, okay, we are going to loop on them. For example, here the PWD will be looped. So here, for example, you will see me printing, for example, the previous value, okay, and then the value after decoding. And this is simply because I want to show you how it works. But surely in a real time or in a real life engagement, this will not be the case. Everything should be silent. There's no output even. Okay, so here, after injecting our packet here, okay, we'll immediately, even before that, run the receiver script here in the victim side or in the receiver side. So in the victim or the receiver side here, it will simply run with root privilege in order to receive your commands using TCP dump. And the reason why I'm using TCP dump here is not because, for example, TCP dump is better or the best tool to use. It's just a showcase. You can literally do anything. You can literally write your own tool. Okay, it's just a showcase of what can you do and how can you implement it. So by running the receiver script here, it will consist of three parts. The first part is the monitoring part, which actually taking specific values from the network, checking for them. If they exist, it will start the conversion and it will start going down to the second part or the second phase or actually the second algorithm. And the second algorithm will be simply decoding, but this time it will not be decoding for the ROT13 because here is actually a reversed algorithm. Because here, when we started by converting our character into ROT13, this simply because our character here was an ASCII, but here is not ASCII. Here's actually a decimal base 10 or a base 10 decimal. Okay, so we need first to convert it from decimal base 10 into an ASCII character. And after converting it from an ASCII character, simply it will be decoded by ROT13. And finally, in the execution, it will be executed using a sub-process. So simply, the main process will be the receiver.py, which is our script. And the command that will be executed will simply be executed in another process. Okay. Here, if we are going to go back again from a high-level perspective, okay, you will see that there is no actual communication occurred here between the two hosts because simply here, the attacker is just sending a random packet in the network. I can even specify any other IP address. It is not required to be the target IP address. It's just going to be random IP address in the network. Random packets actually running in the network. So there is no actual communication. But from the victim side, it's actually monitoring for any packets in the whole network with or sent from a specific IP address with a specific destination port and a specific packet count to capture, and then it will just take it and execute it. So there is no actual network communication in here. Here is some snippet. We'll run the code now for sure, but this is just a simple snippet. Here, for example, I specified the interface and the port and then the packet count. The packet count here was actually 3, okay? And the destination port here will simply be the port that my tool will specify for the data to be sent to. So simply here we can put ports that is not actually being used in the network. Or even we can develop the receiver.py here, for example, and it's as I mentioned, it's so easy to develop. We can just develop the packet to be received from a specific IP address instead of having it receiving the packet from a specific port. And surely the reason here is also for being stealth, because maybe that port will not be used in the network. So it's going to be something new to the network. So it may raise some concerns. But when specifying receiving specific packets from a specific IP address, it will be something different. This also can be changed. But here in our case, I specified a unique destination port to capture. And surely you are here specifying the destination, sorry, the interface that will that the packet or that has an actual connection to the internet that is actually attached to the internet. Sorry, the local network. You can surely do it from the internet, but here I did it in my local network. And here from the from the attacker side, the commander, you are actually specifying the command, specifying the IP address, and even the source IP address if you want to, let's say, fake it or spoof it. And surely you're specifying the delay, for example, the source port, the destination port, etc., etc. And there is a simple note here about the delay. When I was actually developing this tool for the first time, I get a lot of problems regarding the delay. The delay was a big problem for me because I wasn't having literally any delay. It was as fast as I can. And this caused a problem because the destination host wasn't able to put the packets in the right order. So for example, PWD can be turned to literally anything, okay? But now, after adding this delay option, you can increase the delay or even decrease it. I personally recommend having it in 2 seconds delay. It will be better, but surely it's like depends on your infrastructure here. Okay, so now I'm just gonna stop sharing this and I'll start sharing my whole screen for the final demo part here. So we have the Arch Linux machine, which we already took the snippet from, and my attacker machine, which is simply a Mac OS. Now let's just assume that we are going to send that or these packets to this specific IP address. We can change it, but here, for example, I only have this machine. There's no other machines in the network. So simply, I'm playing on the risk that the destination will not be even exists. So here simply, I'm just gonna specify this IP address, but as I mentioned, you can use it against any other IP address in the network, not specifically this machine. Okay, so here, for example, I'm just gonna take the IP address, and now I'm just gonna run the commander.py. Sorry. The commander.py here, as you can see, consists of multiple options: the command, the target, destination port, delay, source, which is the source IP address, and the port, which is simply the source port. And it's actually self-descriptive. Okay, so here I'm just gonna specify the command to be who am I. I'm just gonna run the who am I command in the target host, and then the target IP address itself will be, for example, let's say it will be this IP address, which is the IP address for our Arch Linux machine, and then the destination port will be something random like 9833, and also the delay will be set to 2 seconds, but here I tested it on 1 second and it was running perfectly. And finally, or last but not least, it will be simply the source port. I can just make it anything. I'm just gonna make it like, let's say, um, anything. Okay. And then the port will be, it can be actually the same as destination port. So let's make it 9833. You can surely change it if you want. And surely because here we are going to craft packets from inside the raw sockets in the memory. So we do need to have the root privileges. And to do it simply, yeah, we can do it like that. But before running it, let me just run the receiver script now. So now we have our attacking machine ready for the attack or for exfiltrating the commands to the other machine. But now what about here? We should also run the receiver script here, and surely it's also self-descriptive. You just need to specify the interface that your machine is attached to or attached to the network from, and surely the packet count and the port. So the packet count can be varied. It depends on, for example, how much packets will be sent, how much communications will be initiated between this host and the other host, etc., etc. I'll use as a start, for example, let's say I'll use the interface. Let me check my interface again. So I'll use here my interface to be the ENP0S1. And then the packet count will be, let's say, 12, or let's try 11, for example, in the beginning. And then the port that we will be capturing the data from will be 9833. And now I'm just going to start listening, and here we'll start attacking. I'm just going to enter my password again, and yeah. So here is simply running. It's just now sending the command. Okay, so for example, now after specifying, let's say, the 11 packet counts here, is simply the encoded command after the encapsulation of the collected window packets values now is just this string, which is literally not a real string. It's just like the encoded one here, the rotated string. But after decoding it now, from the base decimal 10 to and after base decimal 10 it's now ASCII, and now from the ASCII to ASCII R213 to the normal ASCII, it's now who am I, and then executed as root. So here simply you can see that simply we literally executed a command on a remote host without even touching that host, without having like any active communication in the host. Surely here was like an active communication because I specified this host to be my destination host, but surely you can change it when you have, for example, a wider network. Okay, and also it was invisible. So this was actually everything for today, for this tool demo. If you have anything you want to ask me about, just ask, and yeah.